Well, your eyes do not deceive you. That is an working RGB display in Yeeps. But technically your eyes do deceive you. Let me show you. This video will not be edited. Because yeah, I'd like to post videos that are unedited. As we get closer, we can see how this actually works. You have the red as the alarm, as the 1x1 alarm light, the green as sliding doors, and the blue as the hidden doors. Now, this was the original design was made by Buddy Ron Jr., I guess. That is his actual channel name. Go support him. However, the reason why I'm making this video is I'm going to show you how I made mine. So, we'll take this apart piece by piece, and I can show you how to make your very own RGB display. First of all, here's the map requirements. You need to have a 64 by 80 by 256 map. Otherwise, you will not be far enough to actually trick your eyes into seeing color. And second of all, you're gonna want a pretty beefy headset. Quest 3 works. Quest 3S, it's gonna be laggy on Quest 3S whenever it's rendering out an image. But still works. And also, please take note, it will be very laggy once you load into a map. If you have issues like that, please do not try and build this. I've seen worse happen. So let's take this apart. Alrighty, now that we have creative mode, I'm going to save a copy of this map, that way I can take it apart. Don't worry about that. The reason why it does that is because there's a lot of wiring and it won't be able to save. So let's first copy the map. This is just for me, okay? Yes, there's 5,698 blocks. And then we're gonna actually take this apart. I'll speed it up. Remember, if you're ever editing a project, you always want to save a copy on like a copy paster. Why? Because I've lost projects to stupid things, to stupid stuff before. Okay? Now we're gonna copy this specific cell. Actually, they should be called pixels. And in total, one pixel is 97 blocks. Don't worry about that. My game just kind of like... You're gonna have that a lot. If you look at the FPS meter, it is down to... whatever frames that is. I don't really care. You'll have some like ups and downs. So let's clear the map. I mean, at least this. Yep. Alrighty. So let's explain the pixel. If we have... Don't worry about that. I'll get to him in a minute. He's my friend. So we can see right here. You want to have the 4x4 sliding doors. The two 4x4 hidden doors, and a lot of alarm lights. So first of all, for the red alarm lights, you can just, first of all, you're actually going to want to look at this. You see this? You see how that's colored? If we come back here, you see all this? Behind here is a lot of senders. And I mean a lot. These go, if you own all the colors, this is your day for you. These go all the way up to the line color. This and this system right here just goes down column by column until it's fully rendered out. So what you actually, you know what? Let's focus on one thing at a time. Let's focus on this system. I call it the renderer. So first, I'm actually gonna have to turn on hidden friends. That way nobody interferes. Okay, so first you want to put this, and you want to put an AND gate with a NOT gate. This makes it so that it will not stay on. If I press it, watch what happens. See? It only sends out a pulse, and it's already going. You can see that. Now, the reason why you want to do that is because this is a very precise renderer. I know it may not matter, but if you paste this into like a wild or you have some friends over, they might try and spam the button, so this is spam proof. Same with over here, the clearer. This button will clear all of the pixels. Now you might be wondering, what do these red, green, and blue buttons do? So you basically click them to turn them on, and then once you've got it done, once you've gotten your desired payload, send it in, it will tick down one by one until it finishes. And once it gets to red, we'll actually see it. So that will appear white to you guys, because it's a recording. For me, it's just red, green, and blue. This is, that over there, most complicated system. This over here, probably not that complicated. And then this is just tedious, okay? That's just tedious. So, what you want to do is you want to make a sender and receiver list. Yeah, that's what I'm going to call it. So you want to send out the glowing white. You can paint these whatever you want. It does not matter if you don't paint these whatever you want, as long as they aren't being used and as long as you know which senders go to what. So we send out the glowing white signal. It goes through here, and it goes through one whole second, and then whatever this is. Same with on the bottom. And you notice that we have variables. You might be asking, well, I mean, if you're smart, you'll be asking, why do we have these if we already have this? And my answer is because you don't want this rendering what's above it. So we want to tick it down. We want to tick it down every time we send out a new signal. And of course, because this is a 6x8, yes, it is a 6x8, not an 8x8. My wiring is clunky, deal with it. I had to make it myself. You want to make sure that this is 8, because that is the amount of pixels in the vertical line. And then also, yeah, send it through here. Now this is what confuses a lot of players. I cannot believe this keeps on deleting itself. I don't know why it does this. It does it every time. But, yeah, so you might think that this is complicated. It's really not. All you have to do is just cycle through all the paint colors, specifically on this row, and then just paste them up above 8 times. And then you want to put in all the different colors for the senders and receivers. And you see these AND gates. This right here is what controls the color. This determines what row you're putting on, and this sends out the signal, turning it into that color. So for my case, this is red, this is green. No, actually no. This is red, this is green, and this is blue. You can make it in an entire different order. It was harder for me to make it in that order. I really don't care. I'd like to see it. And by the way, the original creator, Buddy Ron Jr., I guess, he said that he was going to make a tutorial. I asked for full permission to upload this. He said it's okay as long as I give him credit. So yeah. I was a little bit too impatient, so I made the system myself. And back to the main part. We just want to cycle through all these colors till you get to lime. If you own all the colors, you want to wait till you get to lime. If you don't own all the colors, just cycle through whatever colors you have. You have to have at least a bare minimum of 18 colors, 18 different colors. Well, actually, you're gonna want hold on. You're gonna want at least 24. I don't think that number is correct. Hold up. Let's see. Yeah, 24. That I was correct the first time. You're gonna want 24 colors. Doesn't have to be. The last 8 don't have to be glowing. They just have to be 24 colors. And you want to do these colors first. Again, doesn't have to be glowing, just noticeable. You want to do these colors first, Then you get to work on the LED. Now we get to the fun part. And by the way, if you just skip to this part, I recommend going back. It's very important to know everything. I don't want you having to watch it a second time and then get angry that it's not working because you skipped ahead again. Okay, so you can see in this specific pixel, all of them are active, which makes white, of course. So you have the red, green, and blue. If you can see the sliding... Oops. Don't want that breaking. You can see that the sliding doors, the greens, are slid open. Now, there is a specific distance that you have to do. Usually, you want to put this blue... You want to put 1, 2, 3, I think 4 blocks away, facing this direction. And then you also want to power them on just to make sure that you got it right. And then the blue, so for blue, it's a little complicated, but not that bad. Basically, the blue this is actually ahead of everything else, but the reason is because, look, this door extends out and it will go inwards like that. So you actually need to shift everything back but the blue door to get it all shown. And also, this is optional. It does waste blocks, however, you can cover everything up with the void. Now, I'm done explaining it, but you might be confused, how do I build it? I can show you. In fact, I can speedrun it. So first of all, we're going to want this frame. It has to be 4x4 because, because some things in life have to be it. And you just don't have to ask questions. I'm going to answer them, don't worry. So it has to be 4 because this needs to slide in, but it won't be perfect if it's not 4x4. So you can see that I'm currently building the frame. Oh yeah, and also I'll paint these for your convenience. I'll paint these, I'll just paint these in normal wood color, like this. That way you can see what I'm doing. Okay, so now you want to go to the wiring section and go all the way down, and you want to get this alarm light. You see how it's doing that? If I grab out a flashlight, that way you can tell how deep it goes. Interesting. Okay, you can see there's 1 block here, then there's 1 block here, which actually means that we probably need to move it back by another block. Like that. Can't be right. Well, okay. Once you build the frame, build the blue first, okay? I'm sorry that there's a lot of mistakes. I'm kind of doing this all in one recording. This needs to be on the other side. Nothing, I guess. Sorry, someone just spooked me. Definitely not here, so if we just rotate this, then we should be good. You want the door that looks like this, with 2 outputs for the right side relative to you looking at it. And then let's see if it'll work on this door as well. I want to get it from here. It's definitely not going to work, so I'm just going to flip it over to not waste time. Yes, I know, it looks different. Cry. So once these are both activated, which I'll actually do for your convenience, bink, bonk, they'll make an entire wall. The reason why you need 2 is because 1 is not enough. Let me show you. See? You need 2. Now, make sure that your walls are placed like this. The left one is these 3 inputs are on the bottom, and then the right one, these 2 inputs are over here. Now that we have that done, we can make the alarm lights. Don't worry, they'll only bother you for a second. And also, we can do a check if it blocks them. Okay, yeah, it does block them. We put the alarm lights a bit too far back. Which was on me, I'm sorry, guys. This may not be the most easy tutorial, so I know you might have to be like pausing and checking for a lot of stuff. I'm sorry if that happens, but it is my way. I'm not really good at explaining things. I'm gonna be straight honest. But I'll try my best, that way y'all can replicate it. So first you want to place these wires so that the power can go down here, and then because I have OCD, I want to place that there. I got that OCD because I've broken many projects before with using an all wire. So now if we power this, they'll all turn on and then they'll turn off. Now if you power these two while powering this, you can see that it's like that. Now here's the tricky part. The sliding doors. Why are they tricky? No one knows. But yeah, you gotta position them right. I think my theory is that about at the end of the blue is good. Yep, so you want to position these doors at the end of the blue. Then you want to do this 4 times. The reason why is so that they phase through it, so that you can get an effect like this. Now if we set these all to be on, I swear I hear noises that aren't being made by me. But whatever. So I'm just gonna switch them all on to demonstrate. It will not look like that one over there because it is not finished. And if you want to, you can hide the wiring like me. So you can see that that's it fully on without any modifications or any smart technology, as I'm gonna call it. So now let's actually make the core wiring. We're gonna do the green first because it's actually the most simple, surprisingly. So now if we come over here, I'm actually gonna simplify my design. I'll do that later, but you're gonna want to take this. Oh, okay. You're gonna want to take this, actually, to be honest. Now, why specifically in this shape? Well, it's actually because, man, sometimes I just cannot word. It's actually because, you need room to compact this, surprisingly. So, so this is the scan line, as I like to call it. It does what it says. And then you want to color this, whatever you set to green, the sender, whatever you colored over there, green, for this specific row, color this. So now, if we go test it, and don't worry about that one, that will turn on its own. I did not link up that, oh wait, no, it's just all because it's behind. So, let's test it out. Now, of course, in this version, it is going to use the same one as that one, but it's only for demonstrations. You can see that they go out. Am I crazy or... Hold on. Okay, no, I'm not crazy. I am crazy. So, I know it is a little hard to see here. Let me add a barrier back here. That way y'all can see it a little bit better. There we go. So now you can see this. It's protruding, but not too much to cover up these lights. So you can see once it receives the green, it will check if it's on the scan line. If so, it will send an SR lat. It'll send a signal for the SR latch to turn on all these, and then once it receives the reset signal, it'll stop the SR latch. Now basically you want to copy this to over here as well. So the blue one is actually a little bit different than you might think. And here's why. Because you need to connect these two without getting in the way of the screen. One way that you can do it, like me, is I use hidden wiring. This is your choice if you want to add hidden wiring or not. In this case, I will add hidden wiring because you may not know how to do disconnect. I'm not saying that you're dumb. I'm just saying you may not know how to do it. So you want to add a hidden T-wire. And then you want to go across. Corner wire. Short wire. Now, we actually might want this to go up. That way, or... Yeah. And you don't want it to face this way because that's where the red circuit is going to go. But I'll get into that in a minute. Now, because we're building it this close, we're going to want to do that. You want to make sure that it's in a 4x4 area as well. Because, again, pasting this over another one. So, let's see. Then we want to grab an AND gate over here. And because this one's going to be hidden, I think, yeah, like, if you ever want to, you could always cover this top part. Your choice, not mine, whatever you're using it for. But, like, let's say that you covered this piece. You're going to want to put this variable over here. Again, set it to 1, because this is the first row. And then take whatever receiver color that you use for this. And that's the blue done. And we can even see it in action. So now, stop this, clear them all, yep. It's currently going through them all. Alright, big reveal. Now you can see that the green and blue are working. Now for the last part, the red. And I swear, this is the hardest part that it took me to figure it out. So you'll probably figure out everything on your own. But if you think you can, stop watching. Okay, after I do the red, stop watching the video. If you think you can do it. Let's see if you can challenge yourself and learn something new. Now for this one, if you want to stay hidden, which in this case we will put that board right here, take it out, and make sure that it's in a 1x1 area. We want to do the circle like that because it literally just makes it just makes it so that it's in here. Now we're gonna take this SR, send it through here. This is our reset function. Then we take this AND gate. And the variable. And again, set it to 1. Now, if we go do this again. Reset. Now you can see that all of our LEDs are working. Now again, if you think that you can do the last part on your own, which is basically copying this 1 pixel, pasting it for a 6x8 length, and then painting them all correctly, you can go ahead and stop the video and finish the build. But if you do not think you can do that, well, let me paste the map back in. Now this is going to be an example, it's not going to be your actual wiring, because of course it is mine, it is clunky, and it is the first version. So now you can, if you notice, if we go across this row, you'll see that there's different receivers. Want to know why? Well, I think you can actually guess. It's because of that control thing over there. If, for every X that you see here, for example, X1, 2, 3, 4, 5, 6, anything on the X-axis has to have a different receiver, and anything on the Y-axis has to have this variable set to the correct number. If If you do both of these things correctly, it will be able to display information properly. Now, so in my design, this is the red, this is the green, and this is the blue. Mess of wires, right? Well, that's just how I like to do it. How I usually like to do it is I would take a paint color and I would just like set it here and just drop all the way down. It automatically paint them all. And you can just do that for everything except for green. For me, at least. It may not be with you, because this is overlapping with this. Alright, well, I think... Okay, so on to the last step. Testing out your LED. With an S at the end. Now, first of all, you're going to want to clear anything that you have on it already. And I have a test configuration for you to see if it works. And I will show the combination after I type it in. Okay, so this is the configuration that you want to do. So the first pixel will be black, the second one will be white, the third will be, I think, purple, the fourth cyan, the fifth yellow, and the sixth blue, seventh green, and eighth red. You want to know why? It's because it tests all these different ones. Because here's the thing. If something doesn't work, it's because you made a problem with the original design, unless it's something with the receivers. And you can verify if it's with the receivers, if you test multiple colors on it, and it doesn't work, but it works with all the others. And then you want to repeat this pattern every time on every single screen to make sure that you got it working. I know it may seem tedious, but it is an effective testing strategy. It's what I used, and I found a lot of bugs with it. Now let's reload it. We're going to clear the pixels. And by the way, guys, make sure you clear the pixels. That way the screen can display new information. If you do not clear the pixels, the screen will stop displaying stuff, but it will retain the information. So, yeah. That is... I think I might have forgotten pixel. That's definitely not a me problem. Yep, that was just a missing pixel for me. That was not a bug. Shh. Alrighty. Yeah. So I already know my screen works. How? Because I wouldn't be showing this video if it didn't. That is basically how you make an RGB screen. Oh yeah, and also, if you really want this to look good, I recommend painting all wood with void. Why? Because it subtracts all the other light and focuses on... Oh no, that's gonna paint something. Well, I'm pasting it back in. Because it subtracts all of the light and it focuses on your light specifically. And with some different combinations that I actually wrote down here, you can take a screenshot or write them in whatever map you're building this in. I specifically did special combinations. Red and green make yellow, green and blue make cyan, red and blue makes purple, and red, green, and blue makes white, as you see. If you found this tutorial helpful, subscribe, and also check out the original guys. The original guy who made this, who I just kind of wanted to make my own because I was tired of waiting for the tutorial. Buddy Ron Jr., I guess. Anyway, see you later. Stop recording.